Okay, hello everyone. Can you hear me? Hello.
Yes, sir. Yes, sir.
Okay, that's great. Okay, just we are waiting 1 minute, then we'll start.
Happy New Year, sir.
Yeah, happy new year, all of you. Okay, so we'll start today's session. So basically, today is our sixth number tab, and today's session may later to discuss about that land use land cover classification, how we can easily apply the different types of machine learning, and then how we can easily apply this type of machine learning technique in Google Earth Engine, and then create the land use land cover mapping or different types of classification result such as agricultural land classification or crop types classification. Okay, so this type of thing I try to explain from beginners to advanced level, then I hope you can really get it, the idea how we can work. And after completing the 3 hours live training, then we talk about the problem solving class for the previous classes. Okay, so let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So let's go. So basically today's session I discuss about that introduction to machine learning in Google Earth Engine, then how to make land use land cover using machine learning, mainly supervised and unsupervised, both of method or both of algorithm, how we can easily use in Google Earth Engine. We'll also discuss about that. In the supervised machine learning, different types of model such as random forest, then classification and regression trees, or support vector machine, or minimum distance. So this type of algorithm, how we can easily apply in Google Earth Engine, and further how we can easily make the map. Okay, so I also discuss about that. And further we also discuss about that land use land cover classification, mainly how to check the accuracy of your land use land cover classification map. We also discuss about that. And we'll also discuss about that calculate the land use land cover classes area, how we can easily calculate the area, and how to add the legend on your map. We also discuss about that. And finally how we can easily export the land use land cover map from Google Earth Engine. Then we can easily use the ArcMap or QGIS software to get the proper map for our research paper or presentation. Okay, so let's go. We'll start one by one. So basically, first of all, machine learning. Machine learning is a subset of artificial intelligence that focuses on developing algorithm and model that enable the computers to learn and make decision or prediction based on the data. And for the present time, there are a lot of uses in machine learning for the different field such as healthcare or finance, marketing, remote sensing, or different types of GIS. As well as we also use some advanced technology such as deep learning. We also use for the remote sensing for the different types of work such as segmentation or object detection. So different types of algorithm we also use in the machine learning. But in Google Earth Engine platform, we are just use some built-in machine learning model. Suppose just like a function, they are already create some function, built-in algorithm in Google Earth Engine for the supervised and unsupervised. So in this case, we simply call this type of function and connect with our data, and then we can easily make the classification. Okay, different types of classification. So first of all, in machine learning in Earth Engine, so basically we can easily apply the supervised and unsupervised both of algorithm. So this is the supervised and unsupervised. Basically, supervised learning, machine learning model, you need the training sample. Okay, so you need the training sample when you apply the supervised classification or supervised algorithm. But when we apply the unsupervised classification, then we don't need any kinds of training sample. Okay, just we are select algorithm or pixel, then automatically make the classification. But when we apply the supervised classification, then we need to take the ground truth sample, or we need to create the training sample or pre-categorized data. Suppose I want to apply the supervised learning for land use land cover. So first of all, you need to create the pre-categorized data. Suppose I want to make the classification for water body, build up, then barren land, and suppose vegetation. So these four classes I need to create the pre-categorized data when I apply the supervised learning. But when I apply the unsupervised learning, then don't need to take any kinds of ground sample, any kinds of pre-categorized data, don't need. Okay, just we apply the unsupervised learning, it automatically make the classification. But supervised learning, when we apply, you must take the training sample. Okay, work with level data, we need to create the level. Suppose I create the level for water, vegetation, build up, barren land, and water body. Then we need to create all of data level, we need to create the level. But when I apply the unsupervised learning, uh, don't need any kinds of level. Okay, just we make the algorithm. Suppose k means clustering, it automatically make the classification or dimensionality reduction. So different types of algorithm we also use for the unsupervised learning. And supervised learning, we are using the random forest, support vector machine, and decision tree or linear regression. Okay, neural network. So different types of model we also use for the supervised learning. As well as another type is that semi supervised learning. Okay, so in this time we are just talk only for the supervised and unsupervised, but further if you also add more study, suppose semi supervised learning, then reinforcement learning. So different two types, in this case I don't discuss, so we just only talk about that supervised and unsupervised. And further we try to apply the supervised and unsupervised and make the land use land cover classification. So now, what is the classifier? So in Google Earth Engine platform, this type of algorithm, suppose random forest, support vector machine, then minimum distance, then classification and regression trees. So this type of method or algorithm called as a classifier. Okay, suppose random forest is one kind of classifier, support vector machine is one kind of classifier, then minimum distance, it's one kind of classifier. So the algorithm which we implement on the classification on a data set is known as a classifier. Suppose I have a data set. So this data set I apply suppose support vector machine. So support vector machine call as a classifier, or random forest, or minimum distance. So which algorithm I implement in my data set, it's called as a classifier. And there are the two types of classification mainly we find out. One is the binary class, and another is the multi-class classifier. Binary class, possible outcome only for two outcome, only possible two outcome we find out for the binary classifier. And multi-class classifier more than two. Okay, suppose when you apply only for the, suppose you want to classify forest and deforestation, only for the two class. Okay, forest and deforestation. So it's one kind of example for binary class. Multi-class classifier, suppose crop types classification, or classification types of using land use land cover classification more than two class. So then we try to use the multi-class classifier. So binary class classifier and multi-class classifier, we need to use some different algorithm. So further we also discuss about that, which algorithm is better for the binary class, which algorithm is better for multi-class, and then we try to use this type of algorithm and make the land use land cover classification. So now what's the process to make land cover classification map in Google Earth Engine? Suppose in this case, first of all, I discuss about the supervised learning method, then discuss about that unsupervised. So supervised learning method, when you apply, just follow this step and then write your code. Then you can easily create the land use land cover mapping using supervised learning method. So first of all, you need to select your study area. Okay, suppose which area you want to work, so simply import your study area. Suppose I want to make the land use land cover map for the Dhaka city boundary, simply import your Dhaka city boundary. Further, you need to choose and filtering your image collection. Okay, suppose if you want, you can choose the Landsat, or if you want, you can also choose the Sentinel. And Sentinel is more better than Landsat because Sentinel provide the only for the 10-meter resolution, but Landsat is 30-meter. But when you apply the historical data analysis, suppose you want to make the map for historical data analysis from 1990 to 2024, so then you must need to use the Landsat imagery, because Landsat imagery is available from 1973. We find out that for Landsat, but Sentinel is available from 2015 or 17 is available for the Sentinel, but Sentinel is higher resolution than Landsat. So when you work for the historical data analysis, then you need to use the Landsat. But when you work only for the present time analysis, suppose present crop types classification or present land use land cover classification, so this type of work when you do, then try to use the Sentinel, because Sentinel provide you the more better image than Landsat. Okay, so after choosing and filtering the image collection, then we need to collect the training point, because in this case we talk about the supervised machine learning model. When you apply the supervised learning model, you must take the training sample, which class you classified. Suppose I want to classify water body, build up, vegetation, barren land. So then you just need to take the training sample, all of classes, which class you want to classify. Okay, just simply take the training sample for water body, build up, vegetation, barren land, or agricultural land, which class you classified, just simply take the training point. Okay, and how we can take the training point? So there are the lot of way. We are also using the different method to collect the training point or training sample from satellite images. Or if you want, you also import your GPS data. Suppose you simply visited your study area and you just take the some GPS location. Suppose you take the GPS location for water body, you take the GPS location for vegetation, you take the GPS location for build up or settlement or any classes, you take the GPS location. GPS location mainly latitude and longitude value, you know about your class. So this type of GPS location we can simply import in our code editor, and further we just extract the pixel value. Okay, then it work as a training point. But in this case we will also use the different types of band combination, and using the different types of band combination we try to extract the different types of information from the satellite images and take the training sample and collecting the training sample or collecting the training point. Okay, and for this step we need to merge all of training point together. Suppose I take the training sample for water body, I take the training sample for vegetation, I take the training sample for build up. So all of training sample just need to merge together, and after merge we just need to select the bands. In this case, basically my target is that I want to extract the pixel value. Okay, all of band. So for that I simply select some band, which band pixel I want to extract. So simply make the list of my bands, and further just extract the pixel value using sample regions function and make a training dataset. Okay, so this type of training sample basically it extract the pixel value, it extract the spectral signature value or spectrum value, it extract all of points, and further it one kind of just make a data set. Okay, so this all of point, all of spectral signature values considered as a data set. So now I got the dataset. So this dataset further we try to split. Suppose this dataset I split into two way, training and testing. Okay. Suppose in this time you can use the different types of ratio randomly. Suppose 70% data I use for train and 30% data for test, or 80% data for train, or 20% data for test. So simply split the data set into training and testing, and then use the train set. And after doing this thing, just we need to create the classifier. After applying the split, mainly testing and training, then create the classifier mainly model. We create the model. Suppose you can apply the random forest or cart or any other model or any other classifier. Just simply create this classifier and then train the model using training data. Okay, suppose I spilled 70% data, so this 70% data I simply connect with my model and train it. After training, we just model connecting with the satellite imagery. Okay, suppose after training, just we create a model. So when I connect this model with my satellite imagery, this satellite imagery create give me the land use land cover classified image. We can easily get the classified image, and it visualize the land use land cover result. We can easily find out from here. After creating the map, further we try to calculate the accuracy. So in this accuracy, we are just call the rest of the 20% data or rest of the 30% data. So this data further we simply compare with our land use land cover result and create the confusion matrix, which we find out that correctly pixel value and wrong pixel value. Okay, and further from here we can easily calculate the overall accuracy, or if you want also kappa accuracy or producer accuracy, consumer accuracy. So this type of accuracy we can easily create from the confusion matrix table, and further just calculate the area. So just follow this process, we can easily create the land use land cover classification map using supervised learning. But when we apply the unsupervised, then we also need to follow the another algorithm. So after discuss the practical things all of topic, then we talk about the unsupervised. So let me open my code editor. Okay. So first of all, you need to import your study area. Which area you want to make the land use land cover classification map? Just simply import. So okay, so let me open my study area from asset tab. Here I already imported my boundary shape file. So further I just import and then I just use it for make the land use land cover classification. Suppose I want to work for the Dhaka city boundary, just I simply import. So now my boundary is imported. It's the default variable name is a table. You can put any name. I put the name suppose RY. Okay. So now I want to visualize my study area on the map. So just put here map.headline called the RY, and then focus on the center. Put here the map.center object. Object is mainly RY, and put the zoom level suppose 10, and then run the code. So now we find out our study area. Okay, so this is the first step when you make the land use land cover classification map. Simply import your study area. So now second step mainly we need to choose and filtering the image collection. We already discussed a lot of time for filtering the image collection for different method or different way. So Landsat Sentinel, you can easily apply both of images for creating the land use land cover classification map. So in this case, I want to use for suppose Landsat. So simply click on the browse data catalog, and you can see the Landsat. And I want to work for suppose Landsat 8. And basically you take the more better result when you make the land use land cover classification using surface reflectance satellite imagery. So just I simply work with the surface reflectance satellite imagery, and this dataset simply choose and further just filter. So let's go try to filter this image collection. Just copy and then paste here, and further just give a variable name. Suppose I put the name is that image. Okay, So now this image collection, further we need to filter. We already know about that, how we can easily filter the image. So just put at the filter bounds with your study area RY. Then suppose filter metadata. I choose cloud cover. Suppose I choose the less than 1% cloud cover imagery, and further put at the specific date. Suppose filter date. I choose it year of 2024. Suppose 1st January from year of 2024 05 12. Okay, and further I just create the median composite. If you want, you can also take the single rate imagery and then also make the classification. In this case I just create the median composite, all of images, and further clip with my study area, which is RY. Okay, so now just try to add the imagery, add the layer, map.add layer, and call this image and run the code. We find out this type of imagery. Okay, so further we also try to add the color or band combination. Okay, before that, okay, if anyone have any question, then you can also ask me, no problem.
Sir, I have a question that जो shape file that you have taken for boundary, did it contain the mountain area?
uh, it's not the mountain area.
Okay, okay. Because I am working on mountainous area, so I face some problem in that. So I want to discuss with that.
Okay, no
But I
problem, we
will.
also discuss in the problem solving class for your own study area, no problem, we also
Okay.
discuss. Okay, okay. So
And one question, sir. If we are using single image for mountain region, which month we can take, for which month we take that file?
okay, so in the mountain region you find out that all of time for the cloud. So when you work with the mountain region, you try to also apply the another function, cloud max function. Okay, so basically just apply the cloud max function, then it automatically remove all of cloud. Or also Landsat is also available for the Sonomax. Okay, so we can easily remove all of Sono or cloud, and then we also get the very neat and clean satellite imagery for the mountain. But in this case, Dhaka city, I can easily find out that less than 1% cloud cover imagery. So that's why I not apply the cloud max or Sonomax. This type of things is not need for that. But when you work for the any region which have all time there the cloud formation or snowfall, then we need to also apply the cloud max function to remove the cloud, or Sonomax function to remove the snow, and then get the neat and clean satellite imagery. Okay, so you also try further face any problem, it's a guide you how we can easily remove the snow, how we can remove the cloud, and get the very better imagery.
Okay, okay, sir.
Yeah, please.
So, would you make sure that this presentation will be recorded in the same this space?
Yeah, it also recorded. Okay, last time I also take this another skin also coming, so that's why it not recorded, but today is it also recorded, no problem. I also check it. Yeah, I'm working, yeah. Yes, so we find out this type of imagery, but this imagery if you check, they're also including the scale and offset value. So basically this type of value when I add with my image, then we also get the more better spectral value or spectral signature, we find out that more better. Otherwise it show the very long value. Okay, so now this type of offset value and scale value, so basically we already know about that. Scale value, basically we need to multiply, okay, with our imagery, all of imagery. And in this case offset value mainly we need to add with the imagery. So in this case all of bands are the same. Okay, only for the one band is different. This band name is that STB10. Okay, in this time STB10 is not need, because STB10 we already use this band to make the LST. Okay, but in this case this band is not need. I just need only for this SRB1, SRB2, SRB3, 4, 5, 6 and 7, and all of are the same scale. So further I simply copy this scale, and further I simply connecting without function. So I just connect it with the median composite image. Okay, just I put here multiply and then paste here, and then add with offset value mainly this value. This will simply copy and paste. So now click to the run. Okay, further we try to add the band combination. Yes, any question?
So I have a question. When we are comparing the land use land cover of different decade or has a comparison, we use it. Then we can use median function or not, or some other function we will use.
So
Because median give it,
yeah,
median give a combination of whole year, या whole specific time na that date range we take.
yes. So in this case, when you work for the decade, suppose you create the median composite the whole year 2024, take the less than 1% and create the median composite. So same thing, suppose you also try to make the median composite in year of 1990, 1st January December, all of image less than 1%, and create the median composite. Then we just compare the two decade, suppose 1992 2024. Okay, or single time period is also possible. Suppose you take the imagery in 2024 from month of January or April or any specific month. So then also try to use take the imagery 1994 January February, and then compare these things. Or you can create the median composite whole year for year of 2024 January December, all of imagery less than 1%, all of imagery, and create the median composite. And this composite also compare with 1990 January December, all of image less than 1% median composite. Okay, it also possible to do it. Okay.
Okay, sir. Thank you.
Okay. Okay, so we try to add the band combination. Suppose red, then green, and blue. Custom stressing of 98% I keep, and then apply, and further import this visualization, and copy this variable name and paste after the object name, and I put its layer name, suppose imagery. Okay. So now this second step is done. Okay, so in the second step mainly we try to add for choosing our image collection, and then with filtering, and we find out this type of imagery. So now I want to use this satellite imagery, and further we try to make the classified, suppose build up, then vegetation or barren land. Okay, so this type of classes or any classes, which class you want to classify it, just you need to take the training sample. Okay, and now how I can take the training sample? So basically there are the lot of way to take this type of training sample. So if you have the ground truth data, so you can simply import this type of ground truth data, and further you can easily take this training sample. Or if you want, you can use the different types of band combination, and further you can extract the different types of object or feature. So in this case I don't have ground truth data, so that's why I want to apply different types of band combination, and then I want to extract the different types of object or different types of feature. So how I can use the different types of band combination I already discussed. So basically in this case normally it's called the true color band combination. True color means that red, green and blue. It also called the natural color, naturally what human eye can see. Suppose we can easily find out the naturally vegetation, find out the this type of things is the water body, naturally you can find out this type of information. We also find out this type of is that build up or settlement. Okay, so it's one kind of band combination, natural color. or RGB, red, green and blue. So we also use some other band combination. Suppose just click on here, and when I apply, suppose near infrared, then red and blue, custom stressing suppose 98%, and now further just apply. So now we find out this type of band combination. Okay, so when we apply this type of band combination, we find out that water body as a black color or dark color. Okay, water body we find out, as well as if you check the vegetation show as a red color. Okay, we find out the vegetation as a red color. Okay, red color display the vegetation, as well as we find out this type of color, it's one kind of barren land. Okay, find out the barren land. So it's one another kinds of band combination. We can easily find out the vegetation. So basically it's very useful area and also water body area. So water body display this type of black color or dark color, we find out the water body, and vegetation show as this type of red color, pixel red color, it indicating about the vegetation, and barren land show this type of color. Okay, so this is one kind of band combination. You can apply this band combination for any study area, then you can find out this type of things. Water body always show as a black color or dark color, vegetation show as a red color all time, I find out. So from here you can easily get the idea, this place is water, this red color is that vegetation, this place is for barren land. We can easily get the one kind of idea. So further we just use it and then take the training sample from here. Okay, so this is one kind of band combination. If you want, you can also use the another one. Just click on here and apply suppose short wave infrared 1, and also then near infrared and blue, stressing 98%. And this type of band combination is also applicable for the Sentinel-2 satellite imagery. Okay, just apply. So now you find out this type of band combination. Okay, this band combination you can easily find out all of vegetation area, green color indicating about the vegetation area, or this type of color indicating about that barren land, we find out that, and it's a water body, we can easily identify. So different types of band combination we are also used to identify different types of feature. Not only for the band combination, we also use the different types of band ratio. Suppose B4 then B5, just use it, this two band, just simply divide it, suppose B4 divided by B5. So then we can easily calculate the band ratio, and there are the lot of use in remote sensing. If I show you some example, practical example, suppose I simply search on the Google, suppose mineral exploration using Landsat 8. So in this case, if you check some paper, suppose just I open it. So this paper, so basically they are discuss about that ratio, how we can easily use the band ratio and identify different types of mineral. We can easily get the idea. Okay, so you can easily extract this type of information also from here. Suppose if you check it, suppose you can see B5 and B4 ratio, basically it's the rock alternation area, we can easily find out. Okay, dark green represent the vegetation, bright green represent possible of rock alternation area, and red and pink highlight the areas of iron oxide. So this type of band ratio you can also apply, and you can easily identify this type of things also. Okay, so further also that you check this type of work, as well as if you simply search here, suppose Landsat 8 band combination, then you also get the different types of band combination you can also get to identify for different types of feature from satellite imagery. Or if you just visit this website, so then you also get that more better information about the band combination, how we can easily use the different types of band combination, and we can identify for different types of feature. Okay, different types of, we can see different types of band combination to identify for different types of feature from satellite imagery. Not only for the band combination, we also use the different types of index, different types of remote sensing index. We already discussed about that, how we can easily calculate the different types of index using Google Earth Engine. So different types of index identify different types of feature from satellite image. Suppose NDVI, using the NDVI you can easily identify for vegetation area. Suppose NDWI, we can easily identify for normalized water index, we can easily identify water body, or SAVI or EVI. So different types of brand combination index or indices we also use to identify for different types of feature from satellite imagery. So in this case, I want to take this training sample because now we talk about the supervised learning. And when you apply the supervised learning, you must need to take the training sample or create the pre-categorized data, okay, or create the attribute data, okay. So now how I can create? Suppose from this satellite images, I want to classify water body, build up, vegetation, barren land. Only 4 class I want to classify. So I need to take the training sample for these 4 classes. So how I can take the training sample? So in this case, if you want to use this type of rectangle or draw shape, sometime it faces this type of problem because you can simply draw the shape, it extract a lot of pixel. And in Google Earth Engine, when it across the limit 5000 element, we face some problem, okay. Then chart is not work, then it's not calculate the area. So it's the better way is that you can simply take the training sample using a marker, okay. Just use some point or marker. So for that, just click on the marker. You can see, just click on the marker, and you can see it added the geometry. And further, just click on the edit layer properties and put the name. Suppose I put the name suppose water. You can put any name. Suppose I take the training sample for water. I put the this name is the water. Then import as feature collection, because in this case I take the training sample more than one feature, call as a feature collection. Then property mainly in this case we set the property name just like a variable. Property will be same all of classes. Suppose I put the property name is for class and set the value for 0. This value is one kind of level. I set the level of water is 0. 0 means water, so I create the level 0. 0 means water. Okay, you can also start from 1, there is no problem, but it also better to use 0. We start from 0, then 1 2 3. Okay, then I put the okay. So now from this type of water sample, simply take some marker. Now how much training sample I take for each classes? So basically it's also depend on your study area, as well as it also depend on your accuracy, okay. Suppose you you take the training sample, but you take this, your accuracy is very low, then further we also need to decreasing or increasing the training sample for each classes. But first phase we take the training sample more than 30, it then we run our model. After checking the accuracy, if you got the very low accuracy, then we try to increasing or decreasing our training sample. But first time we take the training sample more than 30, okay, it's enough for that. But if I get the very low accuracy or this accuracy is not up to 90%, then we try to increasing or decreasing the training sample. Suppose in this case I take the training sample for water body, suppose 36. Okay, okay, so one training sample is done, and further take the another one. So further just click on the new layer. In the new layer, just you can see it added the new geometry. Just click on here. Suppose I take the training sample for vegetation. Just I put here the vegetation and import as same as feature collection more than one, and put the property will be same all of classes, all of land use land cover classes, and set the value for 1. So 1 is the level. I set the level for vegetation is 1. So then further okay. So now you can see it select the vegetation. Just click on, you can see it through the bold, and then further take the training sample for vegetation, mainly this type of green pixel. We take this training sample as a vegetation area. Okay, then we take the training sample, suppose for Berlin. Just click on here and take this name and feature collection. Set the property is the class, and set the value for 2. 2 is the level of Berlin. Okay, first we put the 0, then 1, then 2. So now take the training sample for Berlin. And we find out this type of, it show the dry pixel, but sometime we find out this type of wet pixel. Okay, this type of wet color. So basically this type of things is the wetland. Okay, suppose you just make the separate dry barren land and dry wetland. So then you take the another class for the suppose wet barren land, and also take the staining sample, but in this case I just merge all of barren land together. So just I take the one training sample, and further we try to just take the training sample for dry barren land and wet barren land. But if you want to make the classification also for the barren land and wet barren land, then you also take the another training sample for it. Yes, any question?
So I have a question that we take barren land separate from sandbars or same with it uh, around the rivers.
Yeah, it also possible. For that, just simply take this new training sample, and in this case I try to just merge both of dry and wet barren land. Just take the merge.
Okay. And one more question to discuss about the accuracy. Now, how much accuracy, minimum accuracy is required for that training sample to work?
Okay, I'll also discuss when I talk about that. No problem. Okay, suppose I take this type of training sample for the barren land, and then suppose build up. Just click on the new layer. Suppose I put here build up, feature collection, put the property suppose class, and set the value for 3 for build up or settlement. And for the settlement, for get the more better visualization, it also better we try to use at that natural color. When you apply the natural color, then you also find out this white pixel. So this type of white pixel, it indicating about the barren land, and it's very confusing. Suppose sometime barren land and build up is mixing, but in we also use some different types of remote sensing technique to separate. So further also discuss about how we can easily separate the barren land and build up, because barren land and build up, all those classes are the almost same spectral graph. If you create the graph of the spectral signature value, we find out that almost same. I put it suppose red, then green, and blue. Okay, so we take this trading sample. Okay, so I take this trading sample. Okay, so I take this training sample. If you check, we take the total 4 classes, mainly water, vegetation, barren land, and build up. So after taking this training sample, just we need to merge all of training sample together. So just we take a variable, suppose sample, and then merge all of training sample together. Suppose water, merge with vegetation, then it merge with bare land, then it merge with build up. Okay, so simply merge all of training sample. So now if I check how much training sample I take for all of classes, so just call this variable training just sample. I just simply print it. So now it computed how much feature collection I take. I take total 161 training sample, all classes, mainly total 4 classes. And if you check, it also create the label. Okay, it also create the label for all classes. If you check it from here, just I click on here, you can see it show the label is the 0. Okay, and this is the coordinate about that. Okay. So it means that for this coordinate I use the level 0. It means that this training sample I took for water, because water level is 0. Also check for other, so all points including with their level is the 1. Level 1 means that this point or this point I use to take the training sample from vegetation, because the vegetation value is 1. So we create this type of label data. So now after creating this type of label data, we just need to extract the band pixel value, so, or create the spectral signature value. Is point total 161 points. We extract the band pixel value or spectral signature value we need to create. Okay, so how we can create for this? So for that, just take a variable. First of all, I need to create the bands, basically which band I want to use to extract the band pixel value. So simply make the list all of band pixel value and then create. So for that, just make a list, and in this list I want to add all of band. Suppose SRB1 to 7, all of band I want to including, and I want to extract the band pixel value for all of points, all of bands, SRB1 to SRB7. So for that, just write here SRB1, put here band name SRB2, then SRB3, SRB4, SRB5, then SRB6, and finally SRB7. So this is my band. I simply make the list all of bands, and I want to extract all of band pixel value for each single point. Suppose for this point, what the spectral signature value for all of bands. So here total 161 points, and I want to need every single point. I want to extract all of band pixel value, and this is my data set. Okay, so let's go try to create and want to extract the band pixel value. So for that, just take a variable. Suppose I put the variable name is that training, and I want to extract the band pixel value basically from this image. Just I copy the image, and from this image I want to use only for this band, which band I make the list, and this list is stored in a variable. So just I copy the variable name and then paste here. Okay, so from this image I just select only for those band, which band I want to use to extract the band pixel value, and further just use a function sample regions. Okay, in the sample regions we simply use to get the value. So in the sample regions, if you check all of argument from here, simply write here sample regions. So first one is the collection. Okay, just let me copy from here all of argument and paste here, and further just dictionary close and also dictionary start. So first one is the collection. Collection mainly your training sample. Okay, my collection total 161 training samples. So it is stored in this variable. Just copy and paste it. Then properties. So in this case, properties basically your property name is classes. Property is the same all of classes. Okay, you can see water, also barren land is the same, property name is the same. So in this case it's the same name, all of property, all of classes are the same name, and it also plural form, you can see properties. So when you find out this type of argument which have plural form, it indicating the more than one. Okay, it indicating the more than one, and when you store it any more than one, then we need to create the list. Okay, so for that just put here the square bracket and put your property name mainly class, because all of class are the same property, so that's why. And it also plural form, so when you find out this type of plural form, you just need to mention the square bracket and then put the argument class all time, not only for that, any other uh, argument, just apply the same process. Scale mainly your 30 meter, it's all of band the same, and others not need, just I remove it, it's not need. Just a minute. Okay, so now let's print this data or data set. Simply call this training and run it. So now all of training sample extract the band pixel value. So let's check from here, check the feature. So you can see all of training points, and if I just click, you can see all the properties. So we find out that SRB1, what is the pixel value, SRB2, SRB3, SRB4, SRB5, SRB6, SRB7. So it including total 7 bands spectral signature value for the class 0. Class 0 means water, we find out that. So all of training points extract the band pixel value. Okay, and also including their label, mainly one for vegetation. Okay, so this is my data set. Okay, so now I want to use this data set. In this data set I already create the pre-categorized data, so basically mainly level data, and also extract the band pixel value. So now this data set, further we try to divide, mainly randomly divide the data set into training and testing subset. We create the subset of training and testing randomly. Okay, this data set. So for that, how I can easily separate or spill the data. So for doing these things, just take a variable. Suppose I put the variable name is that suppose data set, and call this training because it is stored all of data. So this data now I want to randomly distribute it, randomly divide it. So for that, simply copy and then paste, and then apply a function, it's called the random column. Okay, so this random column function randomly divided the data. So now how I can divide, I want to divide suppose 70% or 80%. Suppose 70% data I want to use to train my model, and rest of the 30% data I want to use for check my validation or check the accuracy or check the performance of my model. So randomly I do it. So let's go try to separate the data.